Hi students, welcome to my lectures on thermodynamics. In this lecture, we are trying to continue the concept of thermodynamic properties. As I said, in order to define a state, you need to mention the properties like the pressure is this much, temperature is this much, volume is this much. Then you can define a state of a system. A system could be anything. Right? It could be a glass of water, it could be the steam, it could be the gas and liquid system in equilibrium. Anything is possible for a system. For you to define a system, you have to define the properties. Okay? Among the properties, there are two kinds. One is named as intensive property. Second is named as extensive property, and the third one is named as the specific extensive properties. Let us see what are those. Okay, when you define the properties, like there are few properties which are independent of mass. There are properties which are dependent on mass. Okay, the properties which are independent of mass, that is called intensive property, which depends on the mass, are called extensive property. Independent of mass means how much amount of matter is there, it doesn't matter. Those are called independent properties, independent of the mass, which are intensive properties. Extensive properties are those, the value of the property will be changing depending upon the mass. If 1 kg of material having this much property, 2 kg of material is this much, 3 kg and more. So more is the mass, more is the value of the property. Here 1 kg property is the same value, 2 kg the property value will be the same, the 3 kg the property value will be the same. That means doesn't matter how much amount of mass is present. Let us define. For example, there are many properties are there. The one which is independent of mass is the temperature. And another example which are dependent of mass is the volume or energy. Many other things. While we go through the thermodynamics, you will get to know. Let us take a very good example of how I can identify the property like temperature is intensive. The property like the volume is extensive. Take an example. Take a beaker, fill it up with water. Okay? Measure the temperature at the bottom, measure temperature at the middle, or measure temperature at the top surface. Anywhere, if you measure the temperature will be the same. So that is why temperature is such a property which is independent of mass, whether you are talking about 1 kg, 2 ml, 3 ml, 4 ml, 5 ml, or 1 kg, 2 kg, 3 kg, 4 kg, 5 kg. Wherever there is it is independent of mass. Whether it is a 1 liter, same temperature. It's a 2 liter I am considering is the same temperature. It's 3 liter I am considering is the same temperature. That is why it is called independent of mass, which the temperature name it to be intensive property of a system. In the similar way, let us define what is extensive property. I told you extensive property depending upon the mass. Example, if you see, I divide same beaker of the container. If you measure volume from the bottom, okay, from here up to here it is V1, up to here it is V2, V3, V4, V5. V1 is the smallest volume, V5 is the highest volume. That means from the bottom to top, maximum volume is there. From bottom to up to certain height, it is V1, that is less amount I am considering. That means V5 is higher than V4, V4 higher than V3, V3 higher than V2, V2 higher than V1. Okay, that means more is the mass or more is the volume, more is the property. That is why V5 is having the highest value, V1 is having the lowest value. That means if I consider less mass, less is the value. If I consider more mass, more is the value. That means the volume, it is called extensive property. That means it depending upon amount of material in the system. But temperature, it is not, does not dependent of the amount of material. No matter how much amount is the mass, the temperature is the same. So this is a perfect example of intensive property. The third one is extensive property can become intensive property at one condition. Okay, that is means the one which is dependent of mass will become independent of mass. Let us see a very good example. So specific extensive properties, that means this extensive property will become intensive property. At what condition? Specific extensive properties are intensive properties. Example, we already made a judgment that volume is an extensive property. The same volume can become intensive property at one condition. What is that condition? What is the specific volume? It is nothing but intensive property. Specific volume means with respect to 1 kg. That means how much meter cube of material is there for every kg of material. That means I am measuring the volume with respect to the mass. Per 1 kg, how much amount? Per 2 kg, how much volume will be there? Per 3 kg, how much volume will be there? That means the volume, the specific volume, okay, this is called intensive property of volume. So the same volume will become, if it is a specific volume, then automatically it will become intensive property. How? See, I have taken 3 different containers of different volumes. The first one is having 1000 ml, second is 2000 ml, third is 3000 ml. Okay, that means more is the ml, more is the volume. That means the volume is automatically it is dependent on mass. That means if I consider volume, it is a extensive property. What happens? Suppose if I take a sample here, okay, I have removed 200 gram, okay, of this water. Imagine this is water, everywhere it is water. From every container I have removed 200 grams of water. Then what happens to my volume? Specific volume 200 ml. For every 200 grams of volume, mass of, and 200 ml volume will be there. That means if I pick 200 grams of material out of this container, if I measure my volume, it will come out as 200 ml. Then what is my specific volume? 200 ml divided by 200 grams. That means 1 milliliter per gram. Similarly, if I pick again 200 grams of material from this container and measure its volume, again it will be 200 ml only per 200 grams of material I have removed. Again the specific volume is 1 ml per gram. Similarly, if I again pick 200 grams of material and measure its volume, then the volume will be 200 ml. So if I calculate the specific volume, then it will be 1 ml per gram. That means irrespective of volume, whether it is talking about small volume or I'm talking about the big volume, the specific volume is 1 ml per gram. Here is also 1 ml per gram. That means here also 1 ml per gram. That means even though the container volume is changing, the value is not changing. When the value is not changing with respect to the system, it is automatically independent of mass. Then it called intensive property. That means this extensive property like volume can become intensive property like specific volume if you measure the property with respect to unit mass. Okay, that is why there are properties which are in general in thermodynamics: extensive property, intensive property. I hope now you got what are extensive properties and what are intensive properties, what are specific extensive properties. And talk about the properties. Let us talk about the process now. A system is changing from state 1 to state 2. We have to identify, because why we are doing on a PV plot, we are measuring a system is changing from state 1 to state 2. Then what is the case? I have to measure, see, we all have to do these things to find out work and heat requirements. Entire thermodynamics talks about this work and heat requirements. So any process that happens from state 1 to state 2, if you identify what process it is, whether it is a constant volume process, constant pressure process, there are specific formulas to find out heat and work. If you see the PV plot, okay, that means identify the process means identify this line, okay, this line, okay. If it is a constant pressure process, that means, and you can see the pressure is not changing here, only the volume is, if you see, if a constant pressure line, you can see the volume is changing from here to here, whereas the pressure is not changing. See, the pressure is only at this point, but the volume, if you drop a line, the volume is changing from here to here. That means it is called constant pressure process, where the pressure will not change, only volume will change. So there are the specific formulas. If you know a process happened which brought the system from state 1 to state 2, if you know what process it has undergone, you can find out the heat and work requirements as per the process. And you can see this line, okay, is a constant volume process. You can see the volume is not changing here, only pressure is changing from here to here. So this is called constant volume process, okay, because the volume is not changing, only pressure is changing from here to here. You can see the pressures. This is called constant pressure process, volume process. The other name for the constant pressure process is isobaric process. The other name for the constant volume process is the isochoric process. There are other processes are there. Example, other than this constant pressure and constant volume, there are lines, okay, which originating from state 1 and at certain point which is state 2. So depending upon adiabatic process, okay, constant temperature process, okay, polytropic process. Every process, different equations, different work and heat requirements. For example, in general, a process is represented by PV power n equal to constant. When we are talking about the constant pressure process, means if you put n equal to 0 in general, P equal to constant, because on this line P equal to constant. So the equation will be P equal to C. If you talk about this straight, vertical line, volume is constant. So, and constant volume process, this is constant volume. If you put n equal to infinite, don't worry about how the equation have come. A constant volume process, the equation is volume is constant, because here the volume is not changing. Here the pressure is not changing, that is why P equal to constant. In between this, the name it as a polytropic process. The equation, the line equation, okay, is nothing but PV power n equal to constant, and varies from 0 to infinite, okay. The line equation, other than this, if you talk about the n equal to 1, n equal to 2, n equal to 3, n equal to 4 and n equal to infinite, these are the intermediate processes between constant pressure processes and constant volume process. There is a special case. If you go through the regular lectures of thermodynamics, n equal to PV power gamma equal to constant. That means there is a line in between these two where PV power gamma equal to constant. This applies only for the ideal gas. The gamma, ideal gas, for the gamma is nothing but Cp by Cv. You might have gone, somewhere you have came across this particular line, okay. And gamma is nothing, because PV power gamma is nothing but Cp by Z, specific heat capacity at constant pressure divided by specific heat capacity at the constant volume. Ratio of these two will provide the gamma. See, all the process we are discussing here only to identify the lines. Once you know the line, okay, that means you can identify the area under the curves, because area under these particular curves will give work and heat requirements. So that is why it is important to identify a system which is changing from state 1 to state 2, what process it has gone through. Depending upon the process, you have to pick the equation. Depending upon the equation you pick, the heat and work requirements will change. So this is how we are marching ahead. Hope you understood about process, intensive properties and extensive properties. Let us meet with the new video. Thank you very much. See you soon.